Alright guys, so I am going to go over the final lesson here in this video for chapter 3, and I'm going to start the review also. And so again, this is for the statistics class, and so I'm going to go over this problem, the independent practice, the one that I wanted you to do during class. So the following regression analysis indicates the association between the number of hours you spend preparing for a test and the grade you obtain. And so if I'm looking at this, this is the explanatory and the response. So here, this is saying hours preparing for the test, and over here we're saying that this is going to be your eventual grade. This is what I'm trying to measure here. Okay, and so from class you'll see that this value right here, if we have a y hat of a plus bx, this value here is going to be the slope, so b, and this one will be the y-intercept, or a. And remember that the r squared value is really the only one that we need. We don't need this one over here. Okay, so if I actually want to find the equation from the set of data, I would say that y hat is equal to 10.561 plus 9.0756 multiplied by x, where x is equal to the number of hours spent studying, or prepping I should say, for the exam, and your y hat is going to be the predicted test score. Okay, so this is my equation and these are the variables. Okay, so find and interpret the correlation. So guys, remember, correlation has to deal with r. Well, right now I don't have r, I just have r squared, which is 96.7%. So I'm going to go ahead and convert this to a decimal. And if I want to know what r is, all I have to do is take the square root of this. So the square root of 0.967 is 0.983. Okay, so I would say that based off of this, I have a strong, and because over here the slope was positive, correlation. Okay, so as number of hours prepping for a test increases, the grade you get also increases. Okay, so if I was asked to interpret the slope, I would go ahead and excuse me, if I was asked to interpret the slope, then I would look at over here. Okay, so excuse me. Okay, and the last thing I'm going to go over here, interpret the coefficient of determination. So that is actually the r squared value, so I'm not going to do anything there. So 0.967, again, I'm not going over the whole problem with you all here. So, excuse me, what this is telling me is that 96.7% of the variation, again, this can say coefficient of determination or coefficient of variation. Well, let's be a little bit more specific. The variation of the actual test grade that you get, the eventual one, can be attributed to the number of hours spent prepping for the exam. Okay, so I'm going to go ahead and start with the this is the review that we're going over in class. So give me 1 second here, guys. 1 second. So it's good because we can go over a linear regression example, another one like the ones we saw in class. So here, remember, this was my b value, this was my a value, and this is the r squared value. Okay. So question 1 and 2 refer to the output table above, so this one right here. So research at the Venus Candy Company are interested in the amount of candy that consumers are able to extract from their new containers, one handful at a time. Okay, they decide the best measures to use shoe size for predicting the number of M&Ms, or excuse me, N&Ns for their party size container. So shoe size is the explanatory, and really the response is going to be here is going to be, excuse me, the N&Ns in each container. Okay, and so first question is, what's the correct interpretation of the value of 1.23? So remember, when I'm dealing with this equation, okay, it is a plus bx, where b is the slope. So I'm asking to interpret the slope. So the shoe size is the explanatory. So as I increase the shoe size, okay, the number of N&Ns will also, in this case, increase by 1.23. So when I read through these, on average, the increase in the of 1.23 N&Ns for every 1 inch of shoe size is asking me to interpret the slope. So the answer here is A. Okay. Okay. So managers at Shoe Locker decide they will use Venus Candy Company data to help predict shoe size based on the amount of candy that consumers are able to extract from new containers. So what is the new correlation coefficient when switching the explanatory and the response? So, okay, we didn't really explore this a whole lot in class, we did not, but we know that it's positive because the slope is positive. And so the values here will change, the x and the y, but they will stay a positive correlation. So as the shoe size is now over here, and the N&Ns is over here. Okay, but remember, as I increase N&Ns, the shoe size increases, so I still have this type of correlation. Okay, and so even though maybe the slope will change, maybe it looks more like that, these values are still the same distance away from the line, okay, from this predicted line. And so excuse me, the correlation coefficient, okay, that r value does not change. So r does not change. Okay, so I don't have r right now, I have r squared. So if I know r squared is 0.908, Well, then r is going to be the square root of that. Which is 0.953. Which is answer D. Okay. So, next question here. Wildlife biologists and foresters have been working together to quantify the relationship between acorn crops measured in pounds per acre and whitetail brooding success measured in number of fawns born per square mile. Okay, so the following summary statistic was reported. This one right here. Okay, so which is the following is the regression model we can use. So excuse me. So remember here, first thing is going to be what is the explanatory and what is the response. Okay, and so here we are saying that wildlife biologists. Okay, so here the acorns is the explanatory and the fawns is the response. Okay, and so they gave me a lot of values here. Another equation that we have here is r for the b value. The slope is r over sy over sx. Okay, so since I know the acorns is the x, the fawns are the y, I can just grab from here. Standard deviation is 5. Right, for sy is 5. And standard deviation for x is 23. And the r value, remember correlation coefficient is r, so this is r, 0.771. Okay, so I'm going to go ahead and put that in the calculator, 0.771. Okay, which gives me a b value of 0.167. Okay, so this is my slope, and I mean, if I look at the answer choices, there's only oh, sorry, I should have rounded that up. 0.168. Okay. There's only one value in here that has a positive, excuse me, one has a positive slope, but also of 0.168, which is answer A, so that would be it right here. I could find A if I wanted to find the rest of the equation, which is with this equation. However, I can already tell that from here that's the answer. Okay. So, moving forward, consider the two residual plots above. Which is correct conclusion about the respective linear models? So, you guys remember in the residual plot here, I can see a pattern here. So, on this one, I would say linear pattern, not linear pattern, I'm sorry. Linear model, probably not accurate here because I start to see this pattern. Okay, and on this one here at the middle, I don't really see a pattern. It's kind of all over the place. So I think the linear model is good here. So as I start looking through these, okay, neither model appears to be appropriate due to the absence of the linear pattern. Again, you don't need to see a linear pattern here. What you need to see in the residual plot, at least, is that it looks variable around here. So that there is no pattern. So that's not the answer. Plot A appears to be appropriate because there is a clear pattern. Again, a clear pattern is what tells me it is not appropriate. Okay, so that B is not the answer. Plot B appears to be appropriate. Okay, yeah, because there's not a clear pattern, and plot A does not. So yes, this is true, and so my answer here would be C. Okay. Okay, so medical research suggests that the hand strength is a good predictor of heart health. And the plot below represents the residuals from a linear regression. Y hat is equal to 135 minus 0.90x using hand strength in pounds to predict the blood pressure. Okay, so what is the actual blood pressure of the circle point? So right here, guys, remember x here they told me was, excuse me, the hand strength. Okay, so I know that the hand strength is 40. Okay, and the residual they're telling me is -1. So remember, to find the residual, it is the actual minus the predicted. And so I'm looking for the actual. This is what I'm looking for. Okay, and so I could find the predicted value using my equation here. So okay, so I'm going to go ahead and do that. So my predicted value for a hand strength of 40 is 99. And since my residual value was -1, I just plug that in. And here, I mean, you can use nsolve, or you can go ahead and just solve it here. So my y, my actual value is 98, which is answer C. Oh, I'm sorry, not pounds. It's D. I was finding the milligrams of the whatever Hg is. I don't see what it is. So that's the correct unit. So answer choice is D here, and I mean, and that's all there. So again, I look for the second video, which will go ahead and show you how to do we'll work some word problems out there. Okay.